Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your paleo teacher Jen, and it's time for Throwback Thursday. This is Cotylorhynchus. I'm sorry, it's so stupid looking. I mean, it looks like it accidentally shrunk its head with the shrinking machine from Honey, I Shrunk the Kids. You guys seen that? Love that movie, but also, dude, what is with the head? Okay. Let's get serious. This synapsid was found in Oklahoma by William Strain, and then it was named by John Willis Stovall in 1937. That's a fun picture. It can also be found in Texas. Hang on. I thought everything was bigger in Texas. Sorry. The New Mexican in me must make fun of Texas whenever possible. But you guys missed a piece on this animal. There are currently 3 species, though this is under debate. The original came from the Hennessy Formation in the mudstone layers, which were probably deposited by marshes or swamps in a semi-arid climate. It's also been found in the San Angelo Formation, a fluvio-deltaic system on a coastal plain that periodically flooded. Mega monsoons, anyone? Catastrophically flooded. The third formation, the Chickasha, was also a floodplain on the coast with some lagoons. So it seems that Cotylorhynchus liked the beach. And if we look closely at an earlier Permian map, you can see that the panhandle of Oklahoma and the very tip of Texas here were part of this peninsula. So it makes sense that they would be found in beach deposits because that's what we got going on here. So, It was found alongside a variety of animals from each of these formations, including Rhodothoratus, which was a sort of early reptiliomorph, Gnatharitza, which is a lungfish, Diplocalus, an amphibian, Brachydectes, an early tetrapod, Rhynchonkos, another amphibian, Walchia, an early conifer, Chordate, which is another type of conifer, Neocalamites, a primitive horsetail, Orthocanthus, a shark, and Pteranodon, which is another type of synapsid. Cotylorhynchus is in the kingdom Animalia, the phylum Chordata, the clade Synapsida, the clade Caesosauria, and the family Caesidae. Cotylorhynchus could get up to 20 feet or 6 meters in length in the largest specimens. It had a barrel-shaped body, a long tail, and a comically small head. The limbs were short and robust and ended in powerful claws. The highly developed barrel-shaped rib cage indicates the presence of a massive digestive system suitable for ingesting large amounts of low-nutrient plants. You'll see that in a lot of herbivorous animals. They'll have this big barrel gut. I mean, look at cows, look at horses, look at elephants, look at hippos. Barrel guts. The dentition of Cotylorhynchus also shows that it was clearly herbivorous. The front teeth are longer and slightly curved, probably served to gather vegetation in the mouth. The tricuspid marginal teeth, so that's the ones kind of in the back here, were well suited for slicing and cutting vegetation. The hyoid apparatus, so kind of on the chin for us, preserved in some cases, indicates the existence of a relatively mobile, massive tongue, which must have worked in concert with the palatal teeth, so that is teeth on the roof of the mouth. You can see them right there. During swallowing, so the two would work together to help swallow. The tongue had to press the plant pieces against the palate in order to puncture the food with the large palatal teeth, an action which may have served to enhance the cellulitic fermentation of food in the intestine, because plants are hard to digest. There is also a debate among paleontologists who study this animal and its relatives on whether they were fully terrestrial or semi-aquatic. So Everett C. Olson, in particular, considered that the degree of ossification of the skeleton, the relatively short hands and feet, the massive claws, the limbs with very powerful extensor muscles, and the strong sacrum strongly suggest a terrestrial lifestyle. He did not rule out that the casids spent some time in water, but he considered locomotion on land to be an important aspect of their lifestyle. It has been suggested that the very powerful forelimbs with strong and very tendinous extensor muscles, as well as very massive claws, could be used to dig up roots and tubers. However, the very short neck implied a low amplitude of vertical movements of the head, which precluded the large species from feeding at ground levels, so bushwhacker. Now, in 2016, Lambert and colleagues questioned the terrestrial lifestyle. They showed that the bone microstructure of the humerus, femur, and ribs of adults and immature specimens resemble that of aquatic animals rather than terrestrial animals, with a very spongy bone structure with an extremely thin cortex and the absence of distinct medullary cavities. This low bone density would have been a handicap for animals weighing several hundred kilograms and with a strictly terrestrial lifestyle. They also found that the joints between the vertebrae and the dorsal ribs only allowed small ranges of motion of the rib cage, thus limiting rib ventilation. To overcome this, they proposed that a proto-diaphragm was present to facilitate breathing, especially in an aquatic environment. These authors also argue that the arid paleoclimates to which the casid localities correspond are not compatible with a semi-aquatic lifestyle. Of these animals, these paleo environments included a significant number of aquatic habitats, rivers, lakes, lagoons. The arid conditions could have been the reason that the animals would sometimes have gathered and eventually died. In addition, the arid environments have a low density of plants, which would require even more locomotor effort to find food. For this paper, large casids, such as Cotylorhynchus, were mainly aquatic animals that only came on dry land for the purpose of reproduction or thermoregulation. Okay. However, this hypothesis was disputed based on paleontological and taphonomic data, combined with the absence in these large casids of morphological adaptations to an aquatic lifestyle, meaning low bone density of casids identified by Lamberts and crew does not resemble that of semi-aquatic animals, which tend to have a more strongly ossified skeleton to provide massive buoyancy control and increased stability against current and wave action. Cotylorhynchus bone microstructure is more similar to what is seen in animals living in the open ocean, such as cetaceans and pinnipeds, which emphasize high maneuverability, rapid acceleration, and hydrodynamic control of buoyancy. However, their morphology was totally incompatible with the pelagic lifestyle. Thus, it is considered that the available evidence is still insufficient to question the more widely assumed terrestrial lifestyle of casids and Cotylorhynchus. In 2022, Wernberg and colleagues proposed a somewhat different semi-aquatic lifestyle in which large casids, whose bone structure is even more osteoporotic than that of Cotylorhynchus, would be ecological equivalents of like modern hippos, passing part of their time in the water, like underwater walkers rather than swimmers, but coming on land for food, which seems to make more sense. Well, thanks for coming to today's lesson, and make sure you tune in tomorrow. I have the day off, so we're going to have a live field trip, hopefully, as long as there is signal, to see early Permian rocks in Tuala County. So come join me on this fun field trip, and I will fossilize you later.